Okay. Creek, what is the sum of angle 1 and angle 2 and angle 3 in this triangle? 180 degrees. That's absolutely right. Are you all sure that that's right?
Yes.
How are you sure? Because of the triangle sum theorem. Yeah. Did we prove the triangle sum theorem?
During the test?
No, like, have we done it in class? We proven this? Yost, have we proven this? Kimball, have we proven this? We have. But I didn't think you would remember. So, let's talk about it for a minute. How do we know that angle 1 and angle 2 and angle 3, their sum is 180? How do we know that the triangle sum theorem is a theorem? How do we know it's for real, right? So, let's talk about it. So what I'm going to do is I'm just going to draw a line through one side of the triangle, okay? And then I'm going to draw a line through this other vertex. Now, I can draw the line through any side of the three sides of the triangle, and then through the opposite vertex like this. It doesn't have to be these two. This is no special triangle. It doesn't have to be, this one's acute. It doesn't have to be acute. It could be a right triangle or whatever. But what's important is that I draw these lines parallel to one another. Okay, now, start thinking about our parallel line stuff. Right? We know a lot of stuff about parallel lines. Parallel lines with what through them? Transversals through them. That's right. So, let's look at these two sides like they're transversals. So they don't end right there. You want to kind of think of them. Is this starting to ring a bell now? Yeah, okay. I thought it might. So now what I want to do is I also want to look at angle 4 up here and angle 5 right there. What can you tell me about angle 4 and angle 2 and angle 5? Are they a linear pair?
Well, they're a linear trio.
Okay. They're together. The three of them form a straight line, don't they? And so we know that the sum of those three angles is 180. Okay, so I'm just going to write that down. And we can all agree that this angle right here is 180 degrees. And then the angles, angle addition postulate just says that the whole angle is equal to these three angles added together. We all okay with that? Mm-hmm. All right. You see where I'm going yet? Yeah. Okay. So let's talk about angle 4 and angle 1. Yeah? Mason, what's the deal with angle 4 and angle 1? They're corresponding. Oh, wait.
Alternate.
Yeah. But the key there is that they're congruent, right? That's what Mason's saying. They're congruent. So these are alternate interior angles. So the alternate interior angle says angle 1 and angle 4 are congruent. So right here, instead of angle 4, what can we put? Okay, so I'm just going to do that. Kimball, what's the deal with angle 5 and angle 3? That's right. And so right here, instead of angle 5, what can we put? Okay. Now, this thing that I just showed you, the triangle sum theorem, if I would have happened to draw a right triangle, would this still work? Yeah. Yep. Okay. What if I drew let's see. Let's do it this way. What if I drew an obtuse triangle? Would it still work?
Yeah.
Okay, so it doesn't matter what type of triangle it is, the sum of the three interior angles is 180 degrees. Okay, great. Now, here I've got angle 1, angle 2, angle 3, and angle 4. What's their sum?
360.
Why 360?
I just remember there's a.
You just remember. Good. Remembering stuff is good. Cheyenne, you think it's 360?
Yeah.
Chloe, you think it's 360?
Yeah.
About you, Brisian? Cordell? Yeah? Rhett?
Yeah.
You go with yeah. Why?
I remember two triangles together.
Wait, who said triangles together? Cheyenne, that's a smart thing. Keep going.
I don't know, because triangles add up 20 because there's two of them in it.
There's two of them in here?
Yeah.
Really?
You can make it
So you're saying that this quadrilateral, Cheyenne says, is made up of two triangles, right?
Yeah.
And each of those is 180, so together we'd have 360, don't we? Well, what if it was a different quadrilateral?
It's still
How many triangles make up that quadrilateral? How many? Two. There's two triangles there, isn't there? How many triangles make up every single quadrilateral? Two. Right? Two. So what did we say the sum of the interior angles here is? What is it?
180.
180? This one's a quadrilateral, so how many triangles? Two. Now, I can split it there or I can split it here. It doesn't matter, but however we do it, it's two triangles, isn't it? Okay. Now, you wouldn't want to do this and split it again because then you'd be adding these angles in as well. So you'd be adding in an extra 360. Okay. So we're just talking about the angles here. Yes.
What about like shapes with more than four sides and you have to do more than
What if there are more than four? Okay, so here we have 360. It's funny you should ask that question. Here I have a pentagon and a hexagon. Right? It's almost like I knew what you were going to ask me. That was awesome. Okay. Ashlyn, how many triangles do you see in that figure right there? Yeah? So if you start at one of the vertices, doesn't matter which vertex you start at, and you draw all the diagonals you can draw. Now a diagonal goes from a vertex to another vertex that is not adjacent to it. So you can't draw a diagonal from here to here, can you? Okay, but I can draw one to there, right? And I also can draw one to there. Now from this vertex, that is all the diagonals I can draw, two. And in fact, if I were to start at any one of the vertices, what is the most number of diagonals I can draw? I can draw two. So how many triangles do we end up with? Three. So we have 180, 180, 180, which is?
540.
Yeah, 540. 540. Okay, let's go down to the hexagon. So we just start at one of the diagonal, or one of the vertices, doesn't matter which one. So let's say we start here, and we start drawing diagonals. So we draw a segment to every vertex that is not adjacent to it. How many triangles? 4. So we've got 180, 180, 180, 180, which is 720. Okay, so that's all fine. So let's go back. Sides of a polygon. This wouldn't work if it weren't a polygon, right? So what is the fewest number of sides a polygon can have? 4 or 3? 3, okay. Can you make a polygon with less than 3 sides?
Would a circle count? Oh no, that wouldn't be a polygon.
Right, because a polygon has to have straight sides. You can't do 2 sides because you can't close the figure without making some kind of a curve or something, right? And so that's the fewest number. And what's the sum of the interior angles here? 180. And 4 sides? 360. And 5 sides? 540. And 6 sides? 720. And 10 sides? And n sides?
It would be n
What the crap are you talking about, Mr. Collard? N sides. Do you understand what I mean by n sides?
Number of angles. Number of sides.
However many, right? However many there are. Okay? So this is all great. We can figure out, we know the first few, but it would be nice to be able to figure out 10 sides without having to figure out 7, 8, and 9 first, right?
I'm sure there's going to be a formula. That's
Yeah.
N
Oh,
minus
what?
180.
What did you say?
It's n minus 2 times 180.
Did you just remember that?
Yeah.
He always
N subtract 2 times 180. What does N stand for? Number of sides in the polygon. So 3 sides, subtract 2, 1 times 180, 180. 4 sides, subtract 2, 2 times 2, or 2 times 180, 360. So if we subtract 2 from the number of sides and multiply it by 180, subtract 2 from the number of sides times by 180. Is this working?
Yeah.
Subtract 2 from the number of sides times by 180. Subtract 2 from the number of sides multiplied by 180. Okay, so here, if it's got 10 sides, we're going to go 10 subtract 2, which is 8. We're going to multiply that by 180, which I don't know what that is. 1440. Now, if it has n sides, then you take n subtract 2 and you multiply by 180, and that gives us the sum of the interior angles. Okay? So that's our formula right there. So what am I going to ask you to do with this? Well, I'm going to give you some polygon with some random number of sides. And I'm going to tell you what some of them are. Oh. And I'm going to ask you what that missing side is. Are you going to be able to do that? Are you going to be able to figure out the sum of them? 1, 2, 3, 4, 5, 6. Subtract 2 times 180. Okay, 720. Right? So the last one's 120? Doesn't look like 120. Does that matter?
No.
No, it's got to be, doesn't it?
That one doesn't look like that.
And you did remember that this one's how much? 90? Okay. So, what do you think about that? Is that doable? Okay. I think that's a pretty easy example, and you're not going to have to do anything harder than that. You'll be fine with it. Let's talk about the exterior angles. I didn't leave much time for this because it's so dang easy. Exterior angles. Now, an exterior angle means, okay, let's continue this on exterior angle. Continue this one on exterior angle. Continue this one on exterior angle right there. So we have 3 exterior angles. The exterior angle is not this entire bit here. It's just this bit. Okay? And I'm just going to demonstrate this one for you. So if my pen is pointing right there, see where it's pointing? Right along that right there. You okay with that? And I rotate my pen that angle right there. And then I come down to this exterior angle and I rotate it like that. And then I come over to here to this exterior angle and I rotate that much. Where's my pen pointing again? So how far did the pen rotate around? 360 degrees. Okay, so if it's a triangle, what is the sum of the exterior angles? 360. Okay, so what if it's not a triangle?
Sir, there's another formula for it.
There's another formula for it? Better.
I bet it's still just 360.
What? It can't be the same if it's got a different number of sides, can it? So see how I made all the exterior angles? Okay, so let's just start pointing right there. Rotate that much.
You missed one of your exterior angles.
Oh, I'm gonna make him feel bad. There we go. Let's stop. Okay, so there's one, right? There's 2. There's the 3rd one. We come over here. We rotate 4th one, then the 5th one, and then the 6th one. And how far did the tip of that pen rotate around? 360 degrees. So the sum of the exterior angles here is 360. Is it possible Tyler is correct that it doesn't matter how many sides there are? Right. So the exterior angles, now if you added up, guys, if you added up this whole angle and this whole angle, things would be a little different. We're talking about only the exterior angles here. And I don't want you to get the wrong idea that these all have the same measure, but they're all exterior angles, aren't they? Okay? So the sum of the exterior angles of any polygon is how much? 360. Okay? So, can you imagine the problem that you're going to have to do here? Can we find x? And then find the missing angles? 2x plus x plus 89 plus 67, that's a 67, sorry, equals 360. Can we solve that and find x?
Yes.
Make sure to read the instructions, because the instructions might say find x, or they might say find the measure of these missing angles. So you need to then take it and say, well, that angle is this many degrees, and then this one is 2 times that number. Okay? Last bit of the lesson today, these 3 words. Equa, angular. I'll take that one. Equa, remember the other word?
Lateral.
Lateral. And what's that third word? When it's both equiangular and equilateral. It's what everyone over 60 hopes to be.
I was gonna say retired.
Thanks, Carly. Okay, so equiangular means that the every interior angle is going to have the same measure, and also every exterior angle, by the way, but usually we're talking about that. So let me draw an equiangular triangle. What does equilateral mean?
They all have the same length on both sides.
Right. Now, I want to make something clear for you guys. If a triangle is equiangular, it is always equilateral, and vice versa. It cannot be one or the other. Okay? So it's always regular. So a triangle, if it is, stop packing. If it's equilateral, it'll be equiangular, always going to work that way. But that's the only polygon where it has to be both. It can't be one or the other. And we've talked about this before. So I can have any other polygon, and I'm just going to go to a quadrilateral, can be equiangular without being equilateral. It can be equilateral without being equiangular. And it in fact can be both. It can be regular so we can have a rectangle, we can have a rhombus, we can have a square. So it can be equiangular, it can be equilateral, and it can be regular. Got those three words in your head? Now you can pack. Good job, guys.